In this video, we will practice solving trig equations and inequalities. This is AP Precalculus topic 3.10. If you appreciate the content, please give it a like. If you have not yet memorized these 9 trig values, pause the video and memorize the chart right now. Number 7. What are all values of theta on the interval between 0 and 2 pi, where 2 sine squared theta is equal to negative sine theta? Let's get 0 on one side by adding sine theta to both sides. So we have 2 sine squared theta plus sine theta is equal to 0. Avoid the temptation of dividing both sides by sine theta or negative sine theta in order to cancel this out. If you divide by a trig function, you are losing at least one of your solutions. So instead, get 0 on one side and then factor. Sine theta is now a common factor. Think GCF. So let's take sine theta and put it in front of some parentheses. And we can figure out what goes inside of the parentheses by dividing each term by sine theta. 2 sine squared theta divided by sine theta will leave behind 2 sine theta. Sine theta divided by sine theta is 1. So we factored it. We can find the solutions to the overall equation by setting each one of these factors equal to 0. So we need to set sine theta equal to 0. And if we set 2 sine theta plus 1 equal to 0 and solve, we will subtract 1 and then divide by 2. So let's do that in our heads, and we will just write sine theta is equal to negative 1/2. First, let's find where sine theta is equal to 0. Sine theta is the y value on the unit circle, and the y value will be equal to 0 right here at 0 radians, and then the y value will again be 0 right here at pi radians. We have these two solutions so far. Now let's find where sine theta is equal to negative 1/2. We can find the reference angle by ignoring the negative sign and asking the sine of what angle is 1/2. We have memorized that the sine of pi over 6 is 1/2. So pi over 6 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since we want sine to equal negative 1/2, we need to stick to quadrants 3 and 4, where the y value, and thus the sine function, is negative. We can think of pi as 6 pi over 6. So this angle in the third quadrant is 7 pi over 6. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. These are the 4 solutions to the equation, so the answer is B. Number 8. The graph of g is shown above. Which of the following is an expression for g? All of these answer choices are transformations of the parent function tangent x, but they have this positive 1 in the very front. It will be easier to see what the transformations are if we move that positive 1 to the end, like this. The parent function tangent is always increasing, so I'm noticing that this function is a decreasing function from left to right. A vertical translation will not switch tangent from increasing to decreasing. So if A was the answer, we would be looking at an increasing function. So we know that A cannot be the answer. The other 3 answer choices do show a reflection over the x-axis in the very front. That would explain why instead of having an increasing function, we are looking at a decreasing function. It's upside down. I can choose between the remaining options by finding which one has the correct period. The period can be measured from asymptote to asymptote or from point of inflection to point of inflection. This graph has a point of inflection at 0 and another one at 2 pi. so the period is 2 pi. The parent function tangent theta has a period of pi. So if a is the answer, the period should have been pi. But it's 2 pi, so a cannot be the answer. Hopefully you have memorized that given the tangent of b theta, the period is pi over b. So if c is the answer, then the period will be given by pi over b. Well, the b value is 2, so the period would be pi over 2. Well, that's wrong. We already know that the period is 2 pi. So the answer is not C. By the process of elimination, we know that the answer is going to be D, but let's follow through and analyze. The period is given by pi divided by b, and in this case the b value is 1/2, so that's pi over 1/2. When you divide by a fraction, you multiply by the reciprocal. So that means the period will be 2 times pi, which is correct. That's why the answer is D. Number 9. The function j is given by j of x equals 2 times sine x cosine x minus cosine x. Solve j of x equals 0 for values of x on the interval from 0 to pi over 2. So we need to set j of x equal to 0 and solve. So far we have this. I notice that both terms have cosine x in it. So let's factor cosine x out and put it out in front of the parentheses. Dividing the first term by cosine x leaves 2 sine x. And cosine x divided by cosine x is 1. We can find the solution by setting each one of these factors equal to 0. Starting with cosine x equals 0. When we set the second factor equal to 0, we will wind up adding 1 to both sides and then dividing by 2. Doing that in our heads, we have sine x is equal to 1/2. First, let's find where cosine x is equal to 0. Cosine is the horizontal displacement on the unit circle, so we are looking for where the horizontal displacement is 0. So that's going to be right here at pi over 2. We are only allowed to be on the interval from 0 to pi over 2, so we're not going to keep going like we normally would. So pi over 2 is the only answer. Now let's find where sine x is equal to 1/2. We can find the reference angle by asking ourselves the sine of what angle is 1/2. We have memorized that the sine of pi over 6 is 1/2, so pi over 6 is the reference angle. On the interval from 0 to pi over 2, the only angle with a reference angle of pi over 6 is pi over 6 itself. So x equals pi over 6 is the only other solution. These are the two solutions to j of x equals 0 on the interval from 0 to pi over 2. Number 10. Let f of x equal 5 minus 4 cosine x and let g of x equal 7. What are all values of x in the xy plane between 0 and 2 pi for which f of x is less than g of x? We are looking for where 5 minus 4 cosine x is less than 7. Let's isolate cosine x. First we subtract 5 from both sides, so we get negative 4 cosine x is less than 2. Next we need to divide both sides by negative 4. Be very careful here. When you multiply or divide by a negative, you must remember to reverse the direction of the inequality. So we will get cosine x is greater than negative 1/2. 2 over 4 reduces to 1/2. To solve this inequality, we need to begin by solving the equation cosine x is equal to negative 1/2. We can find the reference angle by ignoring the 1/2 and asking ourselves the cosine of what angle is 1/2. We have memorized that the cosine of pi over 3 is 1/2. So pi over 3 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Since we want cosine to equal -1/2, we will stick to quadrants 2 and 3, where the x value, and thus the cosine, are negative. We can think of pi as 3 pi over 3. So this angle in the second quadrant is 2 pi over 3. And this angle in the third quadrant is 4 pi over 3. The cosine of both of these angles is -1/2. Since cosine gives the horizontal displacement on the unit circle, this blue line represents a horizontal displacement of -1/2. We are looking for where the horizontal displacement is greater than -1/2. So we are looking for angles where the endpoint will be to the right of this blue line. Since the domain goes from 0 to 2 pi, we need to begin our rotation at 0 and then move towards 2 pi. What about 0 itself? Is the horizontal displacement greater than -1/2? Well, yes, this endpoint is to the right of -1/2. It's to the right of the blue line. So 0 itself should be included as a solution. As we rotate, we have more solutions as the horizontal displacement continues to be to the right of -1/2. The endpoint is still to the right of the blue line. Until we get to right here. At 2 pi over 3, the horizontal displacement is exactly -1/2. Should this be included? No. We are looking for where the horizontal displacement is greater than -1/2, not equal to. So, the intervals where the solutions exist will go from 0 to 2 pi over 3. But at 2 pi over 3, I'm going to put an open circle. And for my interval notation, I'm going to put a parenthesis. That indicates that 2 pi over 3 itself is not to be included. Picking up where we left off. We have no solutions as we move past 2 pi over 3 because the endpoint, the horizontal displacement, is now less than -1/2. We want greater than. So no solutions between 2 pi over 3 and 4 pi over 3. Right at 4 pi over 3, the horizontal displacement is exactly -1/2. We don't want that either. We don't want equal to, only greater than. So no solution right here. However, after 4 pi over 3, we start to get into additional solutions because once again the horizontal displacement is greater than -1/2. This endpoint is to the right of the blue line. So, to recap, we don't have a solution at 4 pi over 3. So that's going to be an open circle and a parenthesis. However, we do have solutions from 4 pi over 3 until 2 pi. 2 pi should be included as a solution. That's why I'm putting it with a bracket, because at 2 pi, the horizontal displacement is greater than -1/2. We are to the right of the blue line, and that is what we are looking for. Here's the solution written in interval notation, and here it is again as an inequality. Number 11. What are all values of theta on the interval from 0 to 2 pi, for which 2 sine theta plus radical 2 times 6 cosine theta minus 3 is greater than or equal to 0. For a complex inequality like this one, we ultimately need to make a sign chart. But first, make sure you have 0 on one side like this, and name the left side of the inequality f of theta. Before we can find where f of theta is greater than or equal to 0, we need to find where f of theta is equal to 0. Since this is already in factored form, we can go ahead and set each one of these factors equal to 0. I'm going to do some of this in my head. If we set this equal to 0 and solve, we will subtract radical 2 from both sides and then divide by 2. That will leave us with sine theta is equal to negative radical 2 over 2. For the second factor, if we set this equal to 0 and solve, we will add 3 to both sides and then divide by 6. That will leave us with cosine theta is equal to 3 over 6, which reduces to 1/2. Back to the first little equation. Let's find where sine theta is equal to negative radical 2 over 2. We can find the reference angle by ignoring the negative sign and asking the sine of what angle is radical 2 over 2. We have memorized that the sine of pi over 4 is radical 2 over 2, so pi over 4 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 4. Since we want sine to equal negative radical 2 over 2, we will stick to quadrants 3 and 4, where the y value and thus the sine function is negative. We can think of pi as 4 pi over 4, so this angle in the third quadrant is 5 pi over 4. We can think of 2 pi as 8 pi over 4, so the angle in the fourth quadrant is 7 pi over 4. The first factor, and thus f of theta, will equal 0 at 5 pi over 4 and 7 pi over 4. Now let's find where cosine theta equals 1/2. We have memorized that the cosine of pi over 3 is 1/2, so the reference angle is pi over 3. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Since we want cosine to equal positive 1/2, we will stick to quadrants 1 and 4, where the x value, and thus the cosine, is positive. The angle in the first quadrant with a reference angle of pi over 3 is pi over 3 itself. We can think of 2 pi as 6 pi over 3. So this angle in the fourth quadrant must be 5 pi over 3. We now have 4 critical values where f of theta is equal to 0. Let's use them to make a sign chart. Your sign chart should be labeled as f of theta, and you're going to need a row for each one of these 2 factors. Also, the domain is limited to the interval between 0 and 2 pi. So, you should have 0 and 2 pi at the beginning and end of the sign chart. Next, let's put our 4 critical values in order from least to greatest across the top. Next, let's highlight the critical values where the first row is equal to 0. When we set 2 sine theta plus radical 2 equal to 0, we got 5 pi over 4 and 7 pi over 4. These are the only 2 places where the first factor might change signs. So instead of having to test 5 intervals, we really only have 3, beginning, middle, and end. At which values will the second factor equal 0? When we set 6 cosine theta minus 3 equal to 0, we got theta equals pi over 3 and 5 pi over 3. So these are the only 2 places where the second factor might change signs. Now let's decide whether the first factor is positive or negative in each interval. In this first interval, we are allowed to use the 0 as a test value, since it is not one of the critical values that will cause the factor to equal 0. Notice it is not highlighted in orange. So let's plug in 0. Sine is the y value on the unit circle, and at 0 radians, the y value is 0. So if I plug in 0, I get 0. 2 times 0 is 0. That just leaves positive radical 2. So the first factor is positive in the first interval. Let's skip to the last interval, where we are allowed to use 2 pi as a test value. Plugging in 2 pi will have the same result as plugging in 0, since they are both at the same spot on the unit circle. So I don't need to overthink it. If I got positive for the when I plugged in 0, I'm going to get positive when I plug in 2 pi. So that just leaves this middle interval from 5 pi over 4 to 7 pi over 4. Between 5 pi over 4 and 7 pi over 4 is the value of 3 pi over 2. So that's the one I'm going to plug in. The y value, and thus the sine function, at 3 pi over 2 is negative 1. We are down by 1. So 2 times negative 1 is negative 2. So we have negative 2 and then plus radical 2. Radical 2 is smaller than 2. So negative 2 is going to win, and we will have negative, this factor will be negative on this interval. Now let's decide whether the second factor is positive or negative in each interval. For the first interval, we can again use 0 as a test value. So let's plug in 0 right here. Cosine is the x value on the unit circle, and at 0 radians, the horizontal displacement is 1. We are 1 to the right. So cosine of 0 is 1. That makes 6 minus 3, which is positive. Jumping to the end, we can use 2 pi as a test value, and plugging in 2 pi will have the exact same result as plugging in 0, since they are in the same position on the unit circle. So since we got positive when we plugged in 0, we will get positive when we plug in 2 pi. That just leaves this middle interval between pi over 3 and 5 pi over 3. On the interval from pi over 3 to 5 pi over 3, there are many good test values we could use. I'm going to choose pi over 2 because the cosine of an angle is the x value on the unit circle, the horizontal displacement. Right here at pi over 2, the x value is 0. The cosine is 0. So that wipes out this term and just leaves negative 3. So this factor is negative on this interval. What about the overall sign of f of theta in each interval? A positive times a positive is a positive. So f of theta is positive in these two intervals. A positive times a negative is a negative. So f of theta is negative in these two intervals. And a negative times a negative is a positive. So f of theta is positive in this interval. I am about to highlight the solution set of this inequality on the number line across the top. But first, I like to indicate whether these four critical values where f of theta is equal to 0 should be included in the solution or not. Well, we are looking for where f of theta is greater than or equal to 0. Therefore, these critical values where f of theta does equal 0 should be included. I'm indicating that with closed circles. The rest of the solutions will be where f of theta is greater than 0. In other words, where f of theta is positive. So that will be from 0 to pi over 3, from 5 pi over 4 to 5 pi over 3, and from 7 pi over 4 to 2 pi. What about the beginning and the end of the domain? Should those be included? Looking back at the setup, we see the less than or equal to signs on 0 and 2 pi. So 0 and 2 pi can be included in the solution set. And we will include them because f of theta is positive at 0 and positive at 2 pi. Here's the solution in interval notation and written as an inequality. Number 12. Let f of x equal 2 plus 4 sine squared x, and let g of x equal 5. What are all values of x in the xy plane between 0 and 2 pi for which f of x is equal to g of x? Let's set f of x equal to g of x and solve. We need to isolate the sine squared x part. So let's subtract 2 from both sides, leaving 4 sine squared x is equal to 3. Next, let's divide both sides by 4. So we have sine squared x is equal to 3 over 4. We can unsquare this by taking the square root of both sides of this equation. That will leave sine x on the left-hand side, And on the right side we will have plus or minus. And in my head I'm thinking of this. However, when you take the square root of a fraction, you really take the square root of the numerator and the denominator separately. There's nothing I can do with the square root of 3, so I'm going to leave that as is. However, the square root of 4 is 2, so I'm going to have sine x equals plus or minus radical 3 over 2. It's time to find the reference angle by ignoring the plus or minus and asking the sine of what angle is radical 3 over 2. We have memorized that the sine of pi over 3 is radical 3 over 2, so pi over 3 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Since sine is allowed to be positive or negative, we will have solutions in all 4 quadrants. The angle in the first quadrant with a reference angle of pi over 3 is pi over 3 itself. So that's our first solution. We can think of pi as 3 pi over 3. So this angle in the second quadrant is 2 pi over 3. And this angle in the third quadrant is 4 pi over 3. We can think of 2 pi as 6 pi over 3. So the angle in the fourth quadrant is 5 pi over 3. These are the 4 angles on the interval from 0 to 2 pi, where f of x is equal to g of x. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.